Have you ever wondered why spring returns to its original shape when stretched, but clay does not? Why glass breaks but steel bends? Welcome to today's video, where we explore elasticity and plasticity and how forces deform solid materials. In lower classes, we learn that solids have definite shape and size. But is that always true? Even a rigid steel bar bends when large force is applied. So, in reality, no solid is perfectly rigid. All solids deform under forces, some temporarily, some permanently, right? In case of spring, is being stretched and returned to its original shape. Elasticity, that means the ability of material to regain its original shape and size when the deforming force is removed. The temporary change in shape or size due to external force is called elastic deformation. This happens as long as the force is within the elastic limits. But some materials, like mud or do not return to their original state. They undergo permanent change. Such materials are called plastic, and this property is called plasticity. Elastic materials bounce back, and plastic materials stay deformed. Engineering depends on elasticity. While designing buildings, railways, aircraft, even in roadways, engineers must know how much force the material can handle, how much it will stretch or compress with respect to temperature or cold, whether it will return to shape or stay permanently damaged. How do we build lightweight but strong aeroplanes? Why are railway tracks not made completely rigid? They must maintain some gap, right? Why does glass shatter but brass bends? All answers lie in understanding elasticity and plasticity. Have you ever wondered why bridges don't collapse under heavy load? How hydraulic pressure crushes metals so easily? The answer lies in strain and stress, two of the most important concepts in engineering and physics. What happens when force is applied? When a force is applied on a solid body, it may look unchanged from outside, but internally its particles get displaced. If the body tries to regain its original shape, that is because of restoring force. Stress is the restoring force per unit area, whatever the developing inside a material when it is deformed. If you apply a force F on area A, the stress developed is F by A. The greater the applied force or the smaller the area, the higher the stress. Coming to the types of stresses. First one, tensile stress. When forces pull outward like a stretchy body, it is a tensile stress. Next one, compressive stress. When forces push inward or a compressive body, that means pushing a duster, like that is called compressive stress. When forces act parallel to the surface, if you understand what is the parallel application of the force, perpendicular application of the force, you can imagine this clearly. So, when force act parallel to the surface and deform a body by sliding layers, that is shearing stress. Coming to the strain. Strain is the measure of deformation produced by stress. That means the ratio of change to original dimensions. That means if you stretch a wire, its length will be changed from L to L plus delta L. There is a change in length in a delta L. So what is the strain? Delta L by L is the longitudinal strain. That means lengthwise. In a shearing strain, one layer shift relative to another. Coming to the final topic of the day. That is a hydraulic stress. So when a body is compressed equally from all directions, like a ball underwater, the stress is the same in everywhere. That is called hydraulic stress. If you understand stress and strain, you understand the foundation of strength of material. Want the next videos on the young modulus and stress strain curve? Comment below. Don't forget to like, share, subscribe.